Hi there, Jason Hansman. I'm filming in North Bay, Ontario at the Public Library. I'm just going to do some work on physics today. I want to give a big shout out to the North Bay Library and everyone involved for helping this happen, and thank you very much. So the last time we spoke, we talked about my first law on gravity, and I stated gravity, a byproduct of matter moving at a different rate of speed relative to the mass's rotating center while remaining in the same time space. Now today, I'd like to work on my second law. And that is, the first law involves moving in a circle. That's how gravity can be created in a circle, by moving, okay? It's continuous gravitational pull. But gravity can be created other ways, okay? Difference in time, two time bodies, difference in space, moving towards and away from something. So my definition here is a force of either attracting or repelling energy caused by the changing difference in time separating two or more objects. Now, when you speak about time, you're speaking about distance in physics, to my understanding. So what we have here is a wall. So if we have a wall, okay, we have an object moving towards the wall, okay, whatever it is, a box, okay, it's moving towards the wall. You're gonna have space in between here, okay, so space is in between here, okay, empty space, all right, and what you're gonna get is this is gonna push over, and as this pushes over to here, these lines are squished more closer together, okay? We're squishing them in, and they're coming out at the same time. What you're gonna have here is an effect of a compression, an effect of a gravity wave from the compression, the space changing. You're pushing the space out of the way, okay? Empty space is being moved now, because now there's something in it. An empty space wants to remain empty, okay? So you're moving towards it, you're creating a gravity wave here. Now it goes beyond this. Gravity isn't just created here at this wall, because if this wall actually isn't a wall, because nothing is a wall. It's a bunch of individual atoms, either composed of molecules or just atoms themselves. So what you have here is, closer up on the wall, you have a bunch of dots, okay? So this is your wall, and you have the compression waves, and as you're moving closer, they're being compressed, okay? Now, there's space in here as well, and it continues. There's empty space filling up in between the nucleus of these atoms and the electrons. There's still empty space in there, okay? Now this box is coming towards here, and at the same time, we're gonna have, something's gonna be behind here, but who knows how far it is. So we can just leave it as an empty void, but eventually there will be something over here, okay? Whether it's the edge of reality or another object, okay? So this moves over here, there will be a buffering here. Now there has to be some type of calculation for the density of a material and how gravity can be affected on the other side. Because I also believe as this compresses over here, there's less space here, but there will also be space pushed through here. And on the minuteness, we're talking mathematically calculable, like even these forces right here, you can't feel them with your human touch, okay? This is gonna be, calculated mathematically, okay? And then beyond this point, we're talking into like some serious quantum measurements, okay? But there will be a change, okay? And there will be a compression, and the gravity will come out and spread out like this, and there will be a compression, okay? Now, as this box comes in here, this force will be either created, no force can either be created nor destroyed. So what you're gonna have is a resistance. So I'm pushing towards here. As the gravity wave is compressing, it's actually, the gravity is pushing back. It's not sucking in this instance. It pushes back. And the same here, it's pushing towards each other and spreads out and comes out a bit, okay? So that's a little bit of hands-on, or a little bit of board work on my second law, and these are things I still have to work on and things I want to talk with other people in the physics world, but I think that's a pretty cool law, and I'm not sure if it's been talked about before. I like to watch a lot of shows on physics, but I haven't read all the books and all that stuff. Einstein's a hero of mine, I can't lie. Elon Musk too, he's a great guy. I mean, I can't wait to put a Tesla hat on. So we're pretty excited about this stuff. And yeah, so we want one little video.